Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, we're going to talk about part 3 of my Fume extractor. So this was Mark 1 or minimum viable product. So basically it was useless. As you can see, I have no idea what the heck I was thinking doing this sort of cross braces. I actually wanted to reduce the 3D printing time, but turns out it was worst idea simply because now it has way too much air gap. It's clunky. It just does not work. So if you have watched part 1, you understood like what I wanted to do. So this Fume extractor is based on basically all the professional one I have seen. So all the professional from BOFA and all other company, they have two-step process. So they have a filter and then they have activated charcoal. So I did the same thing here. So in my case, I'm using a Bosch car filter. You could use a HAPA filter if you can find it. I could not find it in the size I liked, so that's up to you. And I'm using 120 millimeter fans. Now that was the biggest mess up in my scenario, simply because for some reason it's way too hard to find 3000 rpm 120 millimeter fan. So I tried a lot of fans, and during that process I learned a lot about how these fans are controlled and operated, the tachometer and the PWM and all that jazz. So this fan is the closest I got to what I actually wanted to buy. Is a, you can see it's a normal 120 millimeter like slim fan. It's not slim, it's like it's a standard for computer fan. And if you go into industry, you will generally get a bigger puppy like this. So I got this simply because this company AVC, you may have seen this brand used a lot. So this is a good brand, but I could only find one piece of it and could not find any more. So it's like, okay. After that, I tried this 4-Dot company. It's an Indian company that rebadges fan. It's a common thing to do. However, when I ordered something similar like 3000 rpm normal fan, they gave me fans that were 2000 rpm. I was like, okay, what is this? Then they said like, okay, there's a mix up because they do not update this. The sticker they use is same in all of the fans. So they said there is an issue. Then I was like, returned it, and then I looked into this one because I was trying to find this, could not find it. Then I was like, okay, let's just buy a thicker one. Hopefully this will be high enough rpm. So this is 4000 rpm. That's what it says when I bought it. Here's deal. This is 7000 rpm. This is an industrial fan. It's way too powerful. If my finger goes there, it disappears. The noise is, let's just not even talk about it. The whole reason why I have push-pull configuration in this system, so I can keep the noise down. Thankfully, it's a PWM system, so I can tone it down, but this made the electrics way too tedious, and I have not sorted how the heck I'm gonna finish it as of now. However, I made a decision that this fan structure, you can buy many AC fans, you can buy this slim sort normal fans or whatever have you. It's a common enough structure where the shape, physics and structure will work. So I was like, okay, let's move forward with this part. Let's finish the body. So I made part 2, which was the CAD, how the heck I'm gonna model all the parts and all that. And this is part 3 where I'm like, okay, let's build it. So now let's start with the fact that because of the ludicrously high RPM and the fact that these have enough torque to cause serious damage, I put fan guard on the front. So if I'm putting something like activated charcoal block, it does not grind against the belt, like, you know, blades. That could be bad. So I have this. 2 of them requires it, another of them. So basically I need almost 6 grills to make sure this is completely safe, or safe enough where I can trust it. So let's start assembling it. So you take a fan, you do it. I'm using M3 screws, countersunk ones and nuts. So I'm using a lot of nuts and screws. Why? I have them. That's why. Technically you should use M4 because that's the thread size, but I have M3, so everything around me is for M3. So let me show you how the heck I've already showed you guys how the heck I made the CAD. So let's start. So this will be the frame, and I'm gonna do it. Okay. So I want to make sure the electrical cable comes out all on the one side, so it will be easier in the electric step. So let's I take a screw. I place it from here. Thankfully there is gap here. Some fan designs, I've only seen 1 or 2 of them, but some of the designs do not have basically, yeah. This is a cooler master hole. As you can see, this part is sealed for some reason. Majority of them are not sealed. So the logic of using screws through here actually works. Now why I'm doing through here? Well, it's super easy. Comparatively speaking, it's not convenient, but given the constraints, this is as good as it's gonna get. So I have this. Now here's it has enough thickness there that I should not need to, but I'm putting it because my fingers can go inside, and oops with fingers is not acceptable. Oops. So we are not gonna do that. Now I'm gonna place a nut here. You can use dome nuts also. That will give you a much more polished look. I have a normal nut collection, so I'm using that. Oh, come on. Yep. Okay, I do not need bits, I need socket. Yep. Ta-da! So, now another. I use this. Yes. I just need one or two thread to engage. After that, it's super easy. As you can see, ta-da! Now I have slim ones. I have 4 slim one goes. So, okay, boom. Now be mindful, I'm using this thickness of fan does not mean it has to be only this. It can be any size or shape you guys desire. Like you can use slim fans, but that will have very low airflow. I'm using the fatter ones. You can easily use 120 millimeter without any 25 mm without any issue. It's completely up to you. Let's use another one. Now that's there. Okay, nope. It's a bit finicky to get under the corner, so I have to. Believe it or not, I actually put a lot of thought into how the heck I actually gonna assemble it, and it does pay off. That's why I said Mark 1 is always garbage. It was like I thought in CG it made sense, as in like CAD, it's just CG, computer generated images, it's not real. So holes and all that, I thought it looked good. After building it, I'm like, yep, that's useless. So this will be fan 1. Now I'm gonna, oh, okay, let's not mix this fan. It will be hell of a disaster, annoying disaster at that. Now, okay, now yo, come on, come on. Okay. Yep. That was tedious. Okay. Okay. Now we there. Okay. Oh, come on. Wow. How the heck people do it so easily in other videos? Just one thread, finally. Okay. Now let's do this one. I should use tweezer. I think that will make my life easier. Come on. Okay. Yes. Okay. Now, point. Let's take electric. Although on top one, I do need to use extra gap. I think it would be wise if I mount another fan here. You have to make sure the directionality, so fan push pull. You do not want a scenario where one is pushing, this is also pushing, and air has nowhere to go. It will create. Thankfully, this fan, because it's an industrial fan, it has like stamps on every side where you can see what is the arrow direction. All of the sides have the stamps, so it's quite easy to verify. Subtle things are good about this because I did manage to find the brand that makes this fan. That's why I was so shocked. It's like, how the heck a company can give me much more than I asked for and still mess it up? How? Like, if they would have given me just a normal 3000 RPM fan, I would have been so happy. That's like, for that, they're like 2000. This time they were like, I'm angry, so we're gonna give you more fan than you paid for. Which makes my life unnecessarily difficult. Okay. Oh, come on. Yes. Unfortunately, in this design, I do have to use 6 metal grills for maximum safety. But you may not need 6. 4 may be good, more than good enough if it's not as powerful as this one, because these are like as close to delta fan as you can get without spending way too much money. Come on. Why am I having such a hard time starting a thread? Okay. Come on. That part is working. One more. Ta-da. So I got this. Basically, each structure is reinforcing the other one. So I do not at the end need a lot in order to reinforce these. Okay, this will be the cable side. We got this. One more fan. This will be the size. Okay. I do have a bit of a longer screw for this one, so where's the long screw? Yep. Okay. Yes. If you have dome nuts, this actually would be even more polished, the final output, if you want to design it. This will be handle. I did not had handle properly built, so my option was basically using strings, this time handle. Although I think I went a bit too much in terms of printer time saving. I should have at least 2 of this. It does work, but it's just a bit too much optimization. Over optimize the hell out of this. Okay, now we have this. Where's the second handle? My main focus on this designing was to make sure I have as little print time as possible. I did succeed at it. So if you have a fast printer, you can print surprisingly quickly these things. Each of the section, if a big enough printer, almost all parts would be reliably printed. Yep, last main piece. Ta-da. Whew. Ta-da. And this will be it. Ta-da. Now we add the sides, and you can see that's why I wanted to design the curve here. So this is how it's printed. This is very easily supported if you have watched the CAD part and the screw holes, so I can reinforce it from this side. Now this part is boring and tedious because it's a very long screw on plastic and I do not have any power tools. This will take exponentially long amount of time. Nah, I thought that would be better. It's not. Using a proper screw. And this is necessary in order to make sure that it does not fly off. In terms of air tightness, it's not that tight, but I can make it. Wow. Okay. finally. This part is the most boring, most tedious in the system. Done. Okay, so this part is done. Now we add. I do have printed the bottom part. It's bottom part. Top I have not done because I have not finished the electronics part. That's completely overwhelming right now, but that will be done. I have to use a ESP32 when with a lot of MOSFET. I have to basically learn how the heck MOSFET works, and then I can finally. Oh no, I can't use this. My bad. My bad. It has to be closed first. Okay, now we close it. Yes. I printed it a bit too thin. I should not have done that thin, but it does work. It does do the sealing job. And my end goal would be to put some tape all around to make sure it's completely airtight. Okay. There. I have only 2 layers in this. That is a bit too thin. I think at least I should have patience for 4-layer printing. Okay. I should make a bowstring where I can just ramp it up. And done. Note to self, next time make sure do not need this long of a screw. Although it will not grab if I had a very small one. I would need to put nuts inside. That would be, or threaded insert. Did not wanted to add that to my buying list. I'm spending too much money on have things. Yep. Okay. Ta-da! Dun da da! This is Mark II. Finger safe. Prefer rather than nuts. Completely safe. And this time because okay, and this is the benefit of making something at Mark II. Now I can insert this and pay attention. Whatever filter you buy generally will have a airflow directionality like this as airflow here. So I can put it like this. Airflow. And as you can see, it's like completely tight. Now because I have given the grill here, I can insert the activated charcoal block. This is a 3D printed one. It worked quite well. I'm very happy with this one. I'll share a dedicated video. I think a lot of people can benefit from this. Different projects, of course. And ta-da! Completely tight, no loose parts. Of course, electronics has to be developed and I have to chop these puppies off, but I'm very happy with this. As long as I can drive these fans under reasonable power, basically I need a MOSFET to turn one on, then send PWM signal, then tone it down, then turn one on. Otherwise, if I use any adapter of this sort of size, it will go boom. I'm working on it. Like, these fans are industrial fans, so they need to be treated with a bit of respect. Failure to do so could result in injury or fried electronics. So I'm not rich enough to afford either of them. So this was basically construction of the physical thing. I'm reasonably sure any of you can take this design and make it your own based on any side, because be mindful, you can have two filters, one before the charcoal, one after the charcoal. You could have like a slimmer fan, much thicker charcoal part, because activated charcoal is apparently a very good system for cleaning air or any gases. So this sort of system can be used. You can have a print farm, let's say you have a lot of volatiles, you can have the same thing. In my case, I'm focusing on fume extractor, but same thing. But again, I would urge you to have tapes here in this sort of corners to seal it, like completely seal it. So the more air has to go through it, the better it would be. Handle makes my life easier. You want to make it more professional, use dome nuts rather than just nuts. Everything would be fine. So this was my presentation on basically actually building the damn thing, and I'm quite happy with this. Electronics remains to be seen yet, but we are making progress. Basically this part kicked my ass way longer than I anticipated, but I did got it done. Again, if you have a large print bed, you can print all of this in one and it will be super quick, super easy. Won't even require so many support structure, but it can be done. It's quite easy. I'm happy with this. And again, it's a few layers thick, so should hold out. And again, that's why I have basically the metal grill here. So this part, because it's flimsy, I do not want a scenario where I put charcoal here and it pushes and grinds again the motor hub. That could cause fire. Charcoal burns very quickly. Activated charcoal burns insanely quickly. So thou shall be careful. That's why protection grill. And everything is very tight and neat. This can be cut so this was so far part 3 of this saga of making a professional grade, or as close to professional as I can make it, fume extractor. Hopefully you have guys liked it and you're gonna support me for moving forward, because now is the naughty parts, electronic parts after this. So hope to see you guys in part 4. Thank you and bye.